Q26 5 marks. The equilibrium equation for the reaction of iodine with hydrogen cyanide in aqueous solution is given. At t equals 0 minutes, I2 was added to a mixture of HCN, I- and H+, bring I2 to 2.0 times 10 to the negative 5 moles per liter. After 3 minutes, the system was at equilibrium, and analysis of the mixture found that half of the I2 had reacted. On the axis provided, sketch a graph to show how I2 changes in the solution between t equals 0 minutes and t equals 6 minutes. So it starts at 2. From 3 to 6, I2 is at equilibrium. After 3 minutes, an analysis showed that I2 is half of what was before, and so half of 2 is simply 1, and so you draw a decrease in concentration meeting at 3 minutes. At such time afterwards, it's going to be a constant horizontal line because it's now at equilibrium. Using collision theory, explain the rate of reaction between t equals 0 and t equals 6 minutes. Refer to the I2 concentration in your answer. This question is simply asking you to describe the profile of the sketch that you drew in A. Now, when we are looking at collision theory, there are certain keywords we often use and we have to remember to use. Things like successful collisions, forward rate of reaction, or backward rate of reaction. Now, in this given situation, the best way to answer this question is simply divide the time zones. T equals 0 to t equals 3 minutes, and then t equals 3 minutes to t equals 6 minutes. Now, we know that initially the iodine concentration is at 2 times 10 to the negative 5 moles per liter. Now, the reason it decreases is because it is now with the mixture of HCN reactants. So it's going to promote successful collision with HCN. As it does that, the concentration of I2 is going to decrease. Henceforth, the rate of reaction is going to decrease. But in turn, it is going to promote a net forward reaction. At such time reaching 3 minutes, the equilibrium will be reached. This is when the concentration of iodine is now half the amount as before, and from t equals 3 up to t equals 6 minutes, the iodine concentration is now constant, which means in terms of collision theory, the forward rate of reaction is the same as the rate of the reverse reaction, and now it is at equilibrium. Now let's look at the HSC sample answer. The initial high I2 concentration results in more frequent successful collisions and a high rate of forward reaction. As the reaction proceeds, I2 is consumed, so I2 decreases, so the reaction rate decreases. After t equals 3 minutes, the system is at equilibrium, so the rates of the forward and the reverse reaction are the same, so I2 concentration is constant. Thank you for watching. Please like and subscribe to this channel for more quality contents. I'll see you next time.